Welcome. Today we are continuing our talk about parallelograms. We established a couple of properties last time, and now we're going to introduce some more. First, let's review the properties that we looked at last time. We talked about opposite angles being congruent, and we talked about the consecutive interior angles being supplementary. If you don't know why those angle pairs are congruent or supplementary, please check out this link to our other video. But what about the sides in a parallelogram? Stick with me, we're going to do some drawing here. Let's say we draw a line down from this corner perpendicular to the bottom side. And we'll do the same thing on the other side, but we'll draw it up. So we've got perpendicular lines between those two parallels. And we know parallel lines are always the same distance apart, so those two lines that we just drew are congruent. Now I have these congruent angles in the opposite corners still, but now that I have that, check all those little red pieces. We now have some triangles here that are congruent by angle, angle, side. So remember, all it takes for two triangles to be congruent is to have two sets of congruent angles and one of the non-included sides to be congruent, and we know the triangles are congruent. Once we know that triangles are congruent, we know all of their other corresponding parts are also congruent. So this far left side and far right side of the parallelogram must match. Now you can do a similar thing for the other sides also to prove that the top side and the bottom side are also congruent. But really what we've got here is that opposite sides of a parallelogram are congruent. I'm going to have you try this on your own. Let's say the top side of this parallelogram is 65 inches. How long is the bottom side? Well, now that you know that opposite sides of a parallelogram are congruent, you know that that bottom side must also be 65 inches. Now, even with the diagonals, there's something there too. We know that opposite sides of a parallelogram are congruent, but let's draw in some diagonals. This goes from corner to opposite corner, and then the other corner to the opposite corner. It makes a big X through the middle of your parallelogram. Now, when this cuts through the parallelogram, we're not really sure how it cuts those angles, so let's go ahead and take those marks away. We don't know what's happening there yet. But if you consider that those diagonals are transversals across the parallel sides, we've got alternate interior angles that are congruent. Then you look at the center and we can find some vertical angles that are also congruent. And we know that the sides are congruent, that top side and bottom side. So when you look at this now, we've got two triangles again. And guess what? They're congruent by angle, angle, side. So convenient. And what this means, again, is that any corresponding parts are also congruent. So in that top triangle, we've got this side congruent to this side in the bottom triangle. But aren't those the two halves of that diagonal? What these diagonals do is basically cut each other in half. We call that bisecting. When something is cut exactly in half, it's bisected. So our property that we're adding here is that the diagonals in a parallelogram bisect each other. And that's the one we're going to use now. So if I told you that segment BG equals 9, I want you to find how long segment BD is. So here's our BG equaling 9. Now notice that's only halfway across, but remember it's exactly halfway across. So the other half is also 9. So if we want the entire distance from B to D, we'd take 9 plus 9, and we'd get 18. Another problem that you might see is when they give you the entire diagonal. If I tell you that AC equals 14, that's all the way from corner to corner. And then I ask you to find AG. But AG is only to the middle, which means it's half of the entire thing. So we do 14 divided by 2, and we'd get AG equals 7. So just to summarize, here are the properties of parallelograms that we've talked about from these two videos so far. Opposite angles are congruent, consecutive interior angles are supplementary, Opposite sides are congruent, and the diagonals bisect each other. Thank you for joining me for this talk about properties of parallelograms, and I'll see you next time.